part of the signature. And the analysis engine is kind of the brain behind the IDS. It collects the traffic, looks at the signature database, also it can refer to the log files and critical files already there in the system, and then it can decide whether to raise an alarm or not, and also want to the user, the administrator, monitoring all these things. And sometimes the analysis engine can write back to the log file. So like that's what you will see in your project, that if there's a change that you detected in some critical files in the system, you can write back to the log files that this packet came and that caused some change in this. So you can write back some log files. Okay? Especially with the post-based IDS, you could do that, because if, for example, if there is, that's one of the operating principles of antivirus scanners. What they do is they will have their own files, okay, small files. When we go to the malware chapter, we can look at that more in detail. So, you know, they can be programmed to run for every day, right, at a particular time, say in the morning when the system is not being used by the user, right? So you can run your antivirus scanner every day in the morning, or whenever you want to schedule to run. So what they do is every time they run, they calculate what is called the hash value or checksum of those critical files that they scan. And the system is, say, infected with a virus or any thing, more likely those files ought to be infected too. So when they recompute the hash values will be different. Because once the file is changed, the contents of the file is changed, the hash value of that file will be different. So when the antivirus scanner runs them again, runs it and computes the hash value of those files again, if the hash values are different, it raise an alarm that these files are not supposed to be changed and I see a difference in the hash values, so something wrong is going on. Okay, so that's one of the strategies they employ to detect the presence or possible presence of some virus on a machine. Okay, so and you can also set, that's what we'll do in the project, you can also set which files you want to monitor, user files. So I want this file to be monitored for any update or any change. So if you think this particular file that you wrote will not be changed by anyone else except you, you can program it and you can ask the intrusion detection system, especially a host-based IDS, to monitor it. So if it notices that the checksum or the hash value of that user file has changed, it can raise an alarm to you that it sees a difference in the hash value. So then you can recollect whether you changed it. If you have not changed it, someone else has changed it. So then you can kind of become suspicious that something else is going on in the system, right? So that's how this IDS works, especially the host-based IDS works based on computing the hash value of all these files and kind of alerting the user. Network-based IDS normally works based on the signatures because it acts on the attack traffic, it finds where the packets are coming from, where they're going to. Okay? So they work mostly on IP address and port numbers. Is that clear? Getting an idea between network-based and host-based IDS. So you have all these kind of logical components of IDS. You have the traffic collector, the analysis engine, the database, and to whom you are reporting. And as I said, they operate normally in a promiscuous mode, so that the outside world or even the others inside don't see their presence. Yes?
So, how you compare the network IDS to the package filter firewall? Are they the same?
Their operating principle is almost the same, because a packet filter is also given a set of rules, allow traffic from this IP address or port number and things like that. So like that, a signature database of an IDS will also have allow traffic from this IP address and so on. But still they could be different, that's what they complement each other. If a packet manages to penetrate and cause some malicious activity inside the network, that host-based IDS can, or network-based IDS can detect. It can kind of delegate the firewall, don't allow traffic from that particular IP address anymore. So, yeah, the signatures could be the same on both sides, but you see where they are applied. This is for traffic entering the network, and this is for traffic that has already entered the network. Applied on the top.
And the IDS itself doesn't do anything, just kind of invokes it.
Right. It depends on whether it's active or passive. If it's passive, it just kind of informs others.
Okay.
If it's active, it can kind of fight with the traffic and try to block it by sending, if you remember TCP connection, all those things. So if you're continuing to receive attack packets to a port number, instead of the server, server is what is being attacked, right? So you have a server inside the network that is being attacked. So let me draw this. So you have, say, the network inside, and you have a server running over here, and say a network IDS somewhere over here. So the client is generating all the attack traffic through a TCP connection. So the server has the capacity to what is called reset the connection. So you can kind of terminate the connection once you decide if you don't want the connection. But you keep getting all the attack packets coming to the server. So if a network-based IDS wants to be reactive, what it can do is it can, because it can also see from where the packets are coming from. So it can kind of send a reset packet so that the connection is kind of terminated right away with the client. You don't have to wait for a server to terminate the connection. Whereas a passive IDS will just lights the alarm, but you still let the packets to go, and it's up to the server to reset or block the connection. Okay, so that's the difference between the two.
Dr. Meg,
Yes.
that signature IDS, isn't it subject to like a spoof attack? That's what kind of attacks would hit it?
Yes, it's not. It's subject to the spoof attack. Yeah, it is possible to bypass. As I said, it strictly operates based on rules. So, for example, somewhere I would have a point that tells like, if you could, for example, if the signature tells that some information has to be either in uppercase or lowercase characters, if the attacker knows that, he could replace instead of the characters with a kind of ASCII equivalent. So something equivalent to the attack to the characters, he could replace. They could still cause the damage. But a signature database based IDS strictly operates based on what is the rule. It could kind of not see such traffic. It could allow them. Okay? So it is possible to kind of fool that IDS by sending something equivalent to an attack traffic and make it not to be able to recognize that. Okay? So that's why nowadays the signature based IDS operates mostly based on statistics, which means you analyze the traffic. If it is similar to a signature with a certain probability, it doesn't have to be exactly like probability of 1 to match with the signature. Okay? So if it matches with the signature with say a probability of 0.9 or 0.8, then you raise the alarm that it is somewhat similar to the signature. So you don't wait for it to be exactly matched with the signature. Okay? So that's how they are normally developed now. Okay? And then an anomaly or a heuristic based IDS is similar to signature based IDS because again the signatures are developed as we proceed. So right away you cannot say what are all the good signatures and what are the bad signatures. Okay? So like that, anomaly based also has certain initial classifications, what is kind of good, suspicious and unknown. Okay, so it's like the whitelist and blacklist approach. So as you process traffic and as you observe what is really going on, if I allow a packet, if it really causes any harm to any machine, then you categorize that packet as something malicious, and whoever sends it, you kind of blacklist them and put them in suspicious list. Otherwise, if they don't cause any harm, you put that packet or the source of such packets eventually in the good list. Okay, so that's how you kind of classify traffic. And this is the example I said, some anomaly-based IDS could be model-based, which means you program it to detect some anomaly. Anomaly means what? Irregular or not a normal behavior, right? That's what this means. So you kind of bring in all your artificial intelligence here, but kind of programming it to observe or catch situations that are not really normal, okay? So that they can raise an alarm. And also a state-based IDS, in the sense that the system, say for example a host or a server, you want to monitor its states at different point of time. Okay, so if it changes its states quickly, okay, which is not supposed to change like that, it has to change from one state to another state only at a certain rate. And if it changes states more than that rate, then again the IDS provides an alarm that something is wrong going on with the service. So, okay. So the whole idea is then a signature-based IDS may not be able to detect what? New attacks, which means new attack traffic. So if you have not seen an attack traffic before, right? Because signature is developed based on what you see, right? So if you have not seen a particular kind of traffic that could cause an attack, you don't know whether the incoming packet traffic will cause the attack or not, because you're seeing it for the first time, right? So you allow such traffic with the signature-based IDs. Whereas with the anomaly-based IDs, you allow the traffic, but what if they do anything kind of abnormal, you can kind of raise an alarm right away, right? The signature-based IDs will not be able to do that. Okay. So the anomaly-based IDs, you can kind of capture what is called attack traffic, which you have not seen already. Okay. But that's the trade-off. The trade-off is what? Sometimes the anomaly-based IDs could give rise to what is called false positive. So remember when you looked at biometrics, I think I introduced these two terms, right? False positive and false negative. A false positive means you classify a traffic as malicious even if it's not malicious. Okay? So remember the objective for this is to do what? Is to detect attack traffic, right? That's the objective of an intrusion detection system. So if an IDS classifies the traffic as malicious, but it is not malicious, okay? So classify traffic as malicious, or you can say classify a non-malicious traffic as malicious. So that makes it clear. So the anomaly-based IDS is prone or possible for it to generate more false positives, because even if it's slightly abnormal, if even I log in, I want to change my password, it raises an alarm that someone is changing the password, so it's not normal. But if a regular user wants to reset his password, he could do that, right? So it's not always that you can classify certain actions as abnormal. Okay? Whereas a signature-based IDS, as I said, since it could, so this is a problem with what? Anomaly-based IDS. It could cause some false positives. Whereas a signature-based IDS is liable to generate what is called false negatives. False negatives means what? You allow some malicious traffic that are not supposed to be allowed. Okay? So you can say classify a malicious traffic as not malicious. So the same terminology can be applied to antivirus scanners. You classify some piece of code as a regular code if you are actually a virus code, or vice versa. Okay? So a signature-based IDS is prone to generate a lot of false negatives. The signatures are strictly followed, that's why you go through the statistical approach. And between the two, which is more risky to have? Negatives, right? Because these are the ones that could really cause something harm to your network or to your host. It's okay to have some false positives. The only thing is the user may not be very comfortable if you keep getting the alarms, right? So sometimes you turn off certain things, that's what you do. You say, I don't want an alarm to be raised if this happens or this happens, right? So false positives are okay other than causing inconvenience to the user. Whereas false negatives are really something that you don't want to have, because if you allow them, the network or the host to be affected.
They still get false coverage to the user if it was malicious traffic. If it was a false negative.
Yeah, it's going to cause inconvenience to the user, yes. Other than on the top of causing the damage to the network and the host, yes.
Dr. May, give me an example of what you mean when you say the state changes. What do you mean?
The state change, for example, the number of packets being processed by server. Okay, so as you kind of start the server, right, its load should increase only gradually. So it should not be getting say 1000 packets or 10,000 packets, what you classify as abnormal, quickly within a certain time. And for example, look at the queue of the server, the number of packets in the queue of the server, it should be within a certain range, number of packets in the queue. If it grows abnormally and then comes back to normal and then grows abnormally, so something wrong is going on. So that's what you classify as state change. So you define what you think as a normal rate of state change. If the state change is above that normal rate, then you can classify it as abnormal. Okay? So that's what I have on false positives and negatives. Okay? So it pretty much went over all these things. So network IDS operates on malicious stealth mode, promiscuous mode. So it mainly looks for the traffic coming from the network that can cause any of these attacks and trying to find out from where they are coming. Okay? So the source they are coming from, and they kind of operate at the network periphery or very close to the firewall. Okay? So advantage and disadvantage. You don't need several network-based IDS in your network. So you operate one or two firewalls, you can operate one or two network-based IDS. You don't run an IDS for every host, a network-based IDS for every host. Then it really becomes a host-based IDS, right? So you can have few IDS, and also, which means it's less overkill, because when you look at the host-based IDS, right, you could have observed it. When you run your antivirus scanner, right, on your laptop or personal computer, your machine you feel it is slow because you cannot do the regular things that you are doing. Because some memory, some processing capacity, everything is being taken over by that antivirus scanner. So like that, if you run your host-based IDS, it eats up the resources or some of your resources of your machine, right? So that problem is not with the network-based IDS. Why? Because they're running on a separate machine on which you don't run anything else, right? So from that point of view, it will take less overkill. Okay? On the other hand, if you look at the disadvantage, a host-based IDS doesn't get all the traffic a network-based IDS gets, because a network-based IDS gets everything coming to the network, right? As a host-based IDS only gets traffic that is targeting that host. So a host-based IDS will get very limited traffic compared to a network-based IDS. Okay? And which means it should be a network-based IDS must be able to handle high volumes of traffic. Okay, on the order of say 1 gigabit per second, whereas a host-based IDS may not be required to handle such high volumes of traffic. Right? Whereas a network-based IDS can get the big picture quite easily, because most of the time, if you operate say 2 or 3 network-based IDS within that network, they can coordinate each other. I am seeing some pattern of traffic here, or you seeing the same pattern of traffic from what you are getting, so they can coordinate and they can quickly come up with a big picture of an attack, because they are looking at a global view, right? Because a host-based IDS can look at only from that host point of view. So a host-based IDS cannot detect a network-wide attack very quickly. They can detect attacks only targeting that particular host. Okay?